Hi everyone, this is Mrs. Morgan with Chapter 11, Section 6, Adding and Subtracting Rational Expressions, Day 1. After this lesson, you will be able to add and subtract rational expressions with common and inverse denominators, and you will also be able to find the least common multiple of two polynomials. We are going to find each sum or difference, and the first one's always the easy one with the common denominator. So when you add your denominator, 15, is going to stay the same, and your 4b plus 16b is 20b. We just add those front numbers and keep our variable. Now, 20 over 15 simplifies down. We can divide each of those by 5. And we will get 4 over 3, and our b just stays right where it is. Oh dear. Okay, we are going to find each sum or difference. In this next example, we have inverse denominators, and what I want to draw your attention to is the fact that we know if we have 4 plus negative 5 that it's the same thing as 4 minus 5. I just want you to keep that in your head for now. So we have 3x over 11 minus x and 5x over x minus 11, and what we want is a common denominator, because as you can see right now, not exactly the same thing. What we can do is we can use this fact. Wow, that is really not easy to read. You're going to take that off there. X minus 11 we can actually rewrite as negative 11 minus x in parentheses. And here's the proof. If I were to distribute my negative to both of these, I'd have negative 11 and positive x. Well, with that addition in the middle, I can now flip the order, and I have x plus negative 11. And from before, we know that that can be x minus 11. I don't expect you to really do anything with this. I just wanted to prove that this is true. So when I come up over here, what I can do is I can take my x minus 11 and I can change it to negative 11 minus x. And with this, I now have a plus negative situation going on. So what I can do with that, instead of having plus negative, I can make this subtraction, and I will now have 11 minus x on the bottom. And once I have my common denominator, 3 minus 5x, negative 2x, and my denominator stays the same. Okay, I know that's a lot of text. LCM means least common multiple, also known as the smallest thing that both quantities go into. For example, the smallest thing that both 3 and 5 go into is 15. So we are going to find the least common multiple of polynomials. And how we're going to do that, we're going to start with 12b to the 4th, c to the 5th, and 32bc squared. And we're going to break everything into powers of primes. So really, I just have to break down my numbers here and here. My 12 goes into 3 and 4, and 4 breaks into 2 squared. So I have 3 times 2 squared, and then my b to the 4th and c to the 5th just come down. And 32, oh, I don't like that color. 32 does, well, all of this. So I can change my 32 into 2 to the 5th power, and then my b and my c squared just come straight down. So I'm going to take one of each item, and if there are repeats, I'm going to take the highest power. Now that's really probably a bit confusing. Let me show you. 3, I just have 1 3, so I'm going to take that. Now the 2's, I've got 2 squared and 2 to the 5th. That is a repeat. Make that tiny. That is a repeat. So I am going to take the highest power, which is 2 to the 5th. My b to the 4th and b, again, I'm going to take the highest power, so b to the 4th. And then with my c to the 5th and c squared, again, I'm going to take the highest power. So what I take for my final answer, 3 times 2 to the 5th times b to the 4th times c to the 5th. And if I were to simplify that out, I know 2 to the 5th is 32. So I will have 3 times 32, 96, b to the 4th, c to the 5th. And that will be my final answer, because 12b to the 4th, c to the 5th will fit in, and 32bc squared will also fit into this. This time we're going to be working with a couple of quadratics. And the first thing we're going to do is break everything into powers of primes, which in this case for us is just factoring them out. So I want things that multiply to negative 28 and add to negative 3. And then I will want things that multiply to 7 and add to that negative 8. So when I factor that down, that looks like these guys. X minus 7, x plus 4, x minus 7, x minus 1. Well, I am going to take one of each item, so I'm going to take my x minus 7, I'm going to take my x plus 4. I already have this one, so I don't need to take it, and I'm going to take an x minus 1. So my final answer is just all 3 of these right in a row. And that is our day 1 lesson of 11.6. Please let me know if you have any questions.